Hey everyone, today we are going to solve this really beautiful problem based out of functions. We have a function f(x) which is given by 4 raised to the power x over 4 raised to the power x plus 2. It looks quite symmetric, but it's not really that symmetric. And we have to evaluate this whole expression f of 1 over 100 plus f of 2 over 100 up to f of 99 over 100. We can see, maybe we can try to analyze the terms of this expression that we have to evaluate. We are going from 1 over 100 to 99 over 100. So we can say that we have a total of 99 terms in this whole series, and we want to evaluate the sum of this series or this expression. So before we start solving it, why don't you pause the video and give it a try by yourself and see if you can solve this problem. And in the meantime, don't forget to like the video and subscribe the channel if you are not already subscribed. All right, so if you have done trying, let's try to solve it now. Okay, let me just choose a pen. All right. First and foremost thing, I'll try to evaluate a couple of these terms and see what do we get here. We can find out the value of f of 1 over 100 very easily because f of x was 4 raised to the power x. So 4 raised to the power 1 over 100. And in the denominator, 4 raised to the power 1 over 100 plus 2. Similarly, we can find out the second term, which is f of 2 over 100. And this is 4 raised to the power 2 over 100 divided by something like this. And okay, we aren't getting really something that can be used effectively, so maybe we can try out finding something else. Maybe we can find out f of minus x, and similarly you can try a little bit of a hidden trial and see where we reach. F of minus x is coming out to be 4 raised to the power negative x over 4 raised to the power negative x plus 2. If we simplify it a little bit, we can multiply numerator and denominator by 4 raised to the power x, so that the 4 raised to the power negative x term gets kind of cancelled out. So we will get 1 divided by, we are multiplying 4 raised to the power x in the both numerator and denominator. So we will get 1 plus twice of 4 raised to the power x. Okay, this is again not anywhere close to f of x. F of x was 4 raised to the power x over 4 raised to the power x plus 2. But similarly, you can try a couple of more permutation and combinations. And one particular combination that's really going to work for us is f of 1 minus x. And this is what we are going to evaluate next. Let's try to find out the value of f of 1 minus x. And we'll see the result is coming out to be really beautiful. F of 1 minus x is going to be 4 raised to the power 1 minus x over 4 raised to the power 1 minus x plus 2. We can simplify it. 4 multiplied by 4 raised to the power negative x divided by 4 multiplied by 4 raised to the power negative x plus 2. And again, we can multiply numerator and denominator by 4 raised to the power x, so that in the numerator we will be left with the 4 raised to the power x, and in the denominator we will have 4 plus twice of 4 raised to the power x. Maybe we can simplify it a little bit more, and okay, the numerator is going to be simply 4, not 4 raised to the power x. We can cancel out 2 from both numerator and denominator, and we'll get 2 divided by 2 plus 4 raised to the power x. And this is exactly what I was saying, that this is a particular combination that's really going to work for us, because f of 1 minus x is looking a lot like f of x. If you remember, f of x was 4 raised to the power x divided by 2 plus 4 raised to the power x. So in case of f of 1 minus x and f of x, we have a exactly same denominator, and this is really going to work for us. So what we do here is, let's write down both the values. This is f of x, and f of 1 minus x is similarly coming out to be 2 over 4 raised to the power x plus 2. Really interesting terms. One thing is that we have a same denominator, which is a huge help for us, because variable denominators are really difficult to solve. And second thing that we can notice is that the sum of the numerators of both these terms is coming out to be equal to the denominator. So if we take out the sum f of x plus f of 1 minus x, the magic is going to happen. Let's see. 4 raised to the power x over 4 raised to the power x plus 2 over 4 raised to the power x plus 2. We have a common denominator, so we can directly add the numerators and see what we are getting. We are getting a really simplified expression. We are getting a very beautiful expression. F of x plus f of 1 minus x is coming out to be 1. And this is where the real magic happens. After this, the problem is really easy to solve. This is the result that we are going to use. And now let's analyze the expression that we were supposed to evaluate. F of 1 over 100 plus f of 2 over 100, and next term would be f of 3 over 100. And similarly, we have a lot of terms in between. I'm directly writing the last three terms: 97 over 100 plus f of 98 over 100 and f of 99 over 100. These are the 99 terms that we have. And one thing that we can notice from this result is that whenever we add two functional values where the sum of the arguments is coming out to be 1, here x plus 1 minus x is coming out to be 1. So whenever we add these type of functional values, we are always getting 1. What I'm trying to say, that if we analyze the first term or the first argument and the last argument in this expression, we can very easily see that if I call this argument 1 over 100 as a, then this is nothing but 1 minus a. And similarly, if I say that, okay, 2 over 100 is, let's say, b, then 98 over 100 is coming out to be 1 minus b. And we can use same logic for all the terms. So basically what we are saying is that we have pairs. We have a total of, I think we have total of 99 terms. So I can say that this expression has 49 pairs of the form f of a plus f of 1 minus a. Right, so f of 1 over 100 is paired with f of 99 over 100. Similarly, f of 2 over 100 is paired with f of 98 over 100. And similarly, we can form other pairs as well. So we have a total of 49 pairs, and we have one extra term because total we had 99 terms, and 49 pairs basically means 98 terms. So one extra term that we have, that is the middle term, f of 50 over 100. This is the term that is occurring only once, and we don't have a pair for this one. So we can say that our original expression is coming out to be 49 times sum of these pairs. And we know that sum of these pairs is going to be 1 irrespective of the value of a. So f of 1 over 100 plus f of 99 over 100 is coming out to be 1. Similarly, f of 2 over 100 and f of 98 over 100 is also coming out to be 1. So this is what we are getting: 49 pairs whose value is 1 plus one extra term f of 50 over 100, which is nothing but f of half. And f of half is really easy to calculate. We will get f of half is 4 raised to the power half divided by 4 raised to the power half plus 2. We can solve this expression. This is coming out to be 2. So we have 2 over 4. So we are getting 49 plus half, that is 49.5. So this is finally what we are getting, and a really interesting result that we have got here, that this whole expression is coming out to be f of 98 over 100 plus f of 99 over 100, and this complete sum is coming out to be 49 plus half, that is 49.5. Right, so this was a very interesting problem, and the best part about this question was the result that we got, f of x plus f of 1 minus x. This was the basically foundational result that we have used to solve this particular problem. And before I wrap up the video, there's one more thing that I want to tell you here, that if we have any function which looks somewhat like this, f of x equals to a raised to the power x over a raised to the power x plus a raised to the power half, somewhat like this, we can use exactly same logic to solve this problem, and we will always get same result. Let me solve it for you in just 1 minute. F of 1 minus x will come out to be a raised to the power 1 minus x over a raised to the power 1 minus x plus maybe a raised to the power half. And if we multiply a raised to the power x in the whole expression, we will get a over a plus a raised to the power half into a raised to the power x. We can again cancel out a raised to the power half from both numerator and denominator, because a can be written as a raised to the power half squared. So we can cancel out this term and we will get simply a raised to the power half. Okay, my pen is not working. Yeah, a raised to the power half over a raised to the power half plus a raised to the power x, something like this. And you can again see that in fx and f of 1 minus x, the denominators are again coming out to be same, and we will get exactly same result, f of x plus f of 1 minus x equals to 1 in this case also. So instead of 4 raised to the power x, you can have any term. It could be maybe 5 raised to the power x, but then the constant will accordingly change, but the result will remain same. In this case also, if I try to find out the value of f of 1 over 100 plus f of 2 over 100 up to, let's say, same 99 terms, f of 99 over 100. So the result is completely independent of the kind of expression that we have. The result really doesn't depend upon the value of a, the value of a that we used here. The result is independent of the value of a. So here also we are going to get exactly same answer, that is 49.5. Right, so this was a very interesting problem, and this question was asked in IIT exam a very long time ago. And you can see that to solve this problem, we really don't need to have a very sound understanding of sophisticated concepts of the chapter functions. We just simply have basic mathematical understanding of manipulating the polynomials, and that is all we need. So I hope all of you like this video. I had really fun making this video. And if you did like it, don't forget to share the video with your friends and subscribe the channel. Thank you very much for watching. Have a nice time.